No, I would not talk about those things off. Yeah, see, now all the kids at home are curious. They're going to listen to this lesson because they're like, what? Yeah. Okay, we're going to talk more about inverses. Find the inverse using points and graphs. Okay, you're going to do a little bit of that, but I want to talk about the other definition of how we actually prove that two functions are inverses. If two functions are inverses, like f of x and g of x, which we don't know right now, if we do f of g of x and we simplify, and we do g of f of x and we simplify, and both come out to be x. That's a requirement. Both come out to be x when we simplify, then they're inverses of each other. It's pretty cool. Now, is it coincidental that we took two inverses and we reflected them over a line? And what was that line? Y equals x. Is that coincidental? I don't know. That's for you to think about when you're at home watching Gilmore Girls and eating kettle corn. Okay. So let's do a couple of these and talk through them. All right, I got two functions. I'm going to plug g into f. Let's see if we get x when we simplify. G, oh yeah, that would make sense, wouldn't it? Which one is g? Oh, okay, great, nice work. Let's call that g. So let's plug g into f. So that's 4 times something, minus 17, that something in this case is going to be g. Look at the cool things that happen. What happens to the 4s? They cancel. Oh, what happened here? What happened here? What a terrible slide. Yeah, I'm pretty sure the other one was supposed to be plus 17, I think. No. Okay, back up, everybody. Just remember that your teacher is finite in understanding sometimes. Let's make that a plus. Okay, that's cool. So that would make this a plus. So that's really awesome because now that plus 17 and that minus 17, they be gone. So f of g of x is x. Okay, cool. If these two functions were what they were when I actually started, then these wouldn't be inverses of each other, okay? All right, well, cool. All right, so then we're halfway home. We have to test the other side as well, and you can already see it coming. I'm going to take g of x, plug f of x into it, and so that's going to be something plus 17 over 4. I'm going to plug in f of x as that something, which is 4x minus 17. And oh, in the opposite order. So weird how this works. The 17s cancel, so I get 4x over 4. And the x's cancel. Excuse me, the 4's cancel, so I get x. I have shown that the two functions, f and g, are inverses of each other. Cool. How about these? Oh, gross. I used the right letters this time. I used the right letters. Let's plug G into F. Are you proud of me? Thank you. I make so much money, you shouldn't be proud of me. I should get this right the first time. Oops, not plus, minus. What the heck? Oh, gosh, that all disappeared. I write too fast, I guess. What am I plugging in here? Ew. 3x plus 1 over x minus 2. And down here, gross. 3x plus 1 over x minus 2. Oh, this is going to be nasty. I've plugged g of x into f of x. Yuck. What do I have to do now? Just erase. Yes, Maureen, I like that idea. Let's erase after we do something like, I don't know, get a common denominator. Common denominator. Okay, let me help you out here a little bit. Let's take the numerator here. Let's distribute a 2. That 2 only goes to the numerator of this rational expression. Right? It doesn't go to both the top and the bottom. Everybody okay with that? So I get 6x plus 2 over x minus 2. If I wanted to make 1 into something with a denominator of x minus 2, I'd put an x minus 2 down here, and I'd also multiply on top. So over here, I get x minus 2 over x minus 2. Let's check the denominator now. Okay, in the denominator, I don't have to distribute, so that's great. But I do have to find a common denominator, so I'm going to turn 3 into, what would that be? 3x minus 6 over x minus 2. Oh, and I got to do the red one with it. Yuck. Almost forgot. I'm going to subtract those two. Whew. Okay, let's simplify. Oh, this is a lot of work. I like it. Embrace it. 6x plus x, 7x, 2 plus negative 2, she gone. All over x minus 2. That's the numerator. Denominator, 3x minus 3x, he gone. 1 minus negative 6, 7. 7 over x minus 2. Sick. Instead of dividing by a fraction, I'm going to multiply by a reciprocal. So instead of dividing by 7 over x minus 2, I'm going to multiply by x minus 2 over 7. Uh-oh. You might see it. I do. What happens to the 7s? They go. What happens to the x minus 2? They go. And I get x. I've only done half the work, though. Hello. Do you want to trust me, or you want to see me do that side of things? You trust me, Joey? After I screwed up the first slide on the notes, you still trust me? Yeah. Okay. So trust me for a second. You people at home or on the World Wide Web, I'm going to pause. Hey, welcome back. I know it's amazing. I just moved from slide to slide with like almost no time in between. We're just cruising right along here. Let's graph a couple of inverse functions. What do we say about x and y when we work with inverses? Take them and flip them. So any point that you see up here, you can go ahead and take and flip the x and y, and then we're going to sketch. So let's take the nastiest looking one up here. How about number h? Yeah, that's good. Number h. Number h. Oh, yeah, that's just straight nasty. Okay, gross. Okay, this point right here is the point negative 2, 0. So I'm going to take and I'm going to translate to 0, negative 2. Okay. Let's call this point here 0, 2. So that's 2, 0. And this point here is 2, 4. So I'm going to go out to 4, 2. Okay, let me see if I can not screw this up. Decent? Decent. Okay. Before I graph the other portion of this, I'm going to make note of that. That's a horizontal asymptote at y equals 4. So I'm going to make a vertical asymptote at x equals what? 4. Okay, that gives me a little bit of help. Let's continue on with our sketch. The point 2,8 becomes the point 8,2. And, oh man, this is yucky. Let's call, what should we call that point? What should we call the values on that? Well, this right here is 4. 4.2 and just over 4. So we're going to call this point 4.2 and how about 4.2? No, that's not right. That's not right. How about 6 and 4.2? Satisfied, Joey? Okay, so let's flip that. And let's go 4.2, 6. That's pretty good. So if we were to sketch, let's use purple. The line y equals x. Oh yeah, that's pretty nice. You're welcome.